Hello, in this session, we evaluate the extraction of aluminium from bauxite. Welcome. Now, bauxite is the chief ore of aluminium, and the bauxite is a hydrated aluminium 3 oxide, as illustrated there. Now, to be able to extract aluminium from bauxite, there are a few preliminary steps in the preparation of bauxite before we ultimately electrolyze it. The first step in the preparation of bauxite for the extraction of aluminium, this is bauxite. We begin by purification. Purification is a process by which we remove the unwanted agents or impurities. So when bauxite is to be purified, we use hot concentrated sodium hydroxide or caustic soda. As we pass caustic soda through the bauxite, it is reduced into a complex, the aluminate radical. Now, this complex is aluminium tetrahydroxide. We take it to the second level where we do the concentration of the ore. Concentration is simply passing through excess of warm sodium hydroxide, and that reduces the tetrahydroxide aluminate into aluminium trihydroxide, as you can see there. So the aluminium tetrahydroxide has been reduced to aluminium trihydroxide by warm sodium hydroxide. The third stage is converting the aluminium 3 hydroxide into aluminium 3 oxide by the process of oxidation. The oxidizing agent, however, at this juncture is carbon dioxide. So as we oxidize the aluminium 3 hydroxide, we readily obtain aluminium 3 oxide, hydrogen ions, and carbonate ions. Once the aluminium 3 oxide has been formed, we discover that its melting point is relatively high. It is 2015 degrees Celsius, a melting point, and therefore we need to lower the melting point for convenience when electrolyzing the ore. Now, to lower the melting point, we use what is known as cryolite. Now, cryolite is trisodium aluminum hexafluoride, and it serves the purpose of lowering the melting point from 2015 degrees Celsius to 800 degrees Celsius, a workable temperature for electrolysis. The final stage in the preparation of aluminium from bauxite is the electrolytic process of aluminium 3 oxide. Let's take a look at that. So for any electrolytic process, we normally have an electrolyte alongside an anode and a cathode. So it's a typical electrolytic process as shown here. Remember, the electrolyte is aluminium 3 oxide. And this electrolyte has electrodes made of carbon rod as the anode, and carbon rod as a cathode. Good. So, given the anode is a positive terminal and the cathode is a negative terminal, what then happens during the electrolytic process? So at the anode, we will have exclusively oxide ions because they are negatively charged, and at the cathode, we would have the aluminium ions because they are positively charged. What happens at the anode is that there is oxidation occurring, and when the oxidation occurs, the oxide ions is changed into oxygen by the loss of 2 electrons. At the cathode, the aluminium captures 3 electrons to form aluminium molten. However, you can see the ratio of electrons is 2:3, which is imbalanced. Remember that electrons are not found in free space. They have to come from one species to the other. So it means the 3 electrons that are used to reduce aluminium must come from the anode. Since the anode gives only 2, it means we have to balance this reaction by multiplying the left side by 3 and the right by 2. So what happens here is times 3 and there times 2, and the net result is we have 6O2 minus forming 3O2 and 6 electrons. On the right we have 2Al, 3 plus, and 6 electrons forming 2 aluminiums. So you can see now we have balanced the equation such that the number of electrons gained are equivalent to the number of electrons lost. And that is virtually what happens during the bauxite electrolysis in preparation of aluminium. As you can see, the aluminium forms in molten state because the temperatures are relatively high. What then are the properties and applications of aluminium? So, the properties vis-a-vis the applications. One, aluminium is silvery gray. Aluminium is silvery gray. Number 2, it is malleable. 3, it is ductile. 4, it is a good conductor of electricity. And 5, it has low density. It is insoluble in water. Now, because of this, we find that aluminium, being silvery gray, can be used to manufacture mirrors. Being malleable and ductile, it can stretch into sheets and can be drawn into wire, and it conducts electricity, so it can be used to manufacture electric cables. It can also be used to manufacture heat appliances because it's a good conductor of heat. Out of its low density, it's combined with magnesium to form aeroplane parts. Remember, an aircraft needs to be light enough for ease in its propelling into the skies. So, as you can see here, aluminium is important, and that is why we are studying it. Thank you. So, as we have said, aluminium is extracted from bauxite by the method of electrolysis. The processes for extracting aluminium from bauxite involve purification, concentration, oxidation, and then once oxidation has occurred, we do the electrolysis. Thank you.